3 to 4 is the humbucker, 5 and 6 are the voice coil, and what they don't show you on here is that there's a third post that's not have anything to do with a secondary winding of the audio output transformer. It's just physically there as a tie point. And so what they do is they just bring this out and tie that to there, and bring this out and tie that to there. And that's how come you get 4 wires looking like it comes out of 3 posts on the output transformer, but you don't see that here at all. So that's what's going on. Hope that helps you guys if you haven't seen it before. So it seems to be working. Well, the patient's starting to have really a lot of problems. This capacitor is just really losing it here. So I'm going to go ahead and cut this thing out and get it out of here. But one of the things I thought I'd do real quick is this cap here that we did the little test on a little while ago, showing that it didn't respond. I thought it'd be kind of interesting to maybe cut it out of the circuit and then see if it then begins to respond. So maybe there's something closed loop around this that maybe it's not really that capacitor, it's something else like the old capacitor. Let's see if I can just cut that out, see if it changes anything. So we're on that setting, nothing changes. Clip it out. Still connected. Nope, it's really bad. Okay, at least we know. Just a quick update. Started taking some things out. So this is that really messy capacitor that was leaking all over the place. I've got it. What a mess. You can see that. But pretty much what you'd expect. So this guy's out. I got the original electrolytic out. The text on it is it's pretty much, I can't read it. It's very dark. I thought it was interesting. It's got 3 leads on it, so it tells me that one of these is common to the 2 capacitors, and I guess it would be this one. But it looked like what they had is they had the 2 positive leads tied together at some of these points in here, and then this other one ran off by itself and tied to the it went to the isolated ground, if you will, not to the one that goes straight to chassis ground. So I'm not sure what was going on with this. But anyway, it's out. Then, as are the other 2 that were the replacements. This is the newer one. It's Grunow Teledial Beaver. This is the one that tested bad on the tester, and I don't see a date code on here, or I don't know what it is. I don't know if you can see that, but. Anyway, so both that one's out, and this one here, this Aerovox apparently had a really delicious covering on it that the bugs loved, so they ate that up. Anyway, so I'm in here and I cleaned some things out. You can see where the original electrolytic used to be. I pulled all the tubes out so I can start to check a little bit of resistances across some of the resistors. When I pulled the caps out, you can see all the little bits and pieces of pigtails that had never been removed. They'd just been cut and J-hooked. And I'm trying not to overheat things, but I'm also trying to get some of the junk out of here. There's an awful lot of solder blobs and stuff, so it's been worked on before. Anyway, I'm going to go through and check some resistors and see what we end up with. So I went through and I checked all the resistors, went down the list, and every one of them I checked is out. They're all reading high except for one which read low, number 11. And 11 is right here on this line between that high bypass capacitor. No, I want to say bypass. That's the coupling capacitor between the plate of 75 to the grid of 41, which voltage was getting real high. That one reads wrong. I think this one does too. It's hard to tell, and it's related to these capacitors. So I'm going to change these two. Unfortunately, I may have to. I don't have these on hand. I'll probably have to double up a couple resistors to get the right voltage. Now I'm just trying to get the thing to work, and then I'll go through. If I get the thing to work, I'll go through and straighten out and get the right proper sizes in there afterwards. In terms of the caps, the one that was bleeding all over the place is this one here. That goes from the B plus to ground. I've got a few caps around here I can use. I may see if I've got a safety cap for that, but for right now, just getting it to work. I'll put one of these in, and then for the for this coupling capacitor, I've got another one of these smaller orange drops I'll use for that. And there's a few other miscellaneous caps I might try to replace while I'm in there just so I can get in, but I don't have all those sizes exactly, so I may have to temporarily do some doubling up on those just until I can get the right sizes in. But as I say, the goal now is just to see if I can get the thing working, and then we'll worry about doing a full electrical restoration on this thing. So we'll worry about that later. So anyway, I'm going to put some of those parts in. Here's the replacements for the electrolytics. I've got a couple of decent, more than decent. I got a couple of Rubicon 10 microfarads, 500 volts for the 450 volt service. So I think I've got what I need to get a run through to see if I can get the thing to operate, and then we'll go from there. Okay, so after some work, we've got some components changed out, primarily on the audio side of the chassis. Went in and did the replacement of the two electrolytics. We have the blue one here, the other one here, and I've also pulled out the original double. And I don't know, I may, when we get around to actually doing a restoration on this, if I do it, I may gut this and see if I can stuff these inside and put it back where it was originally. But meanwhile, I've got the two 10 microfarad 500 volt electrolytics in, and they're in where they're supposed to go. This one was the blue one, and it picked up negative way over here, and so instead of doing that, I just hooked up a line and brought it around here where it tied directly to a chassis spot right here. So that was a good ground. Almost, I think every capacitor in here is reading high. There was one that I thought was reading low, and then when I got it isolated, it was reading high. Instead of being like 560K, it was reading 800 and something K. And the other 560K was reading like 1.3 meg. So they all were reading high. So the ones that were kind of over here on this side, I went ahead and changed out. There's some down in here. The 560K I had to actually gang up. I didn't have an actual value for that, so I put two together in series to do that. A 0.0056 cap I didn't have, so I put together a couple of smaller ones to get me the correct capacitance for this capacitor here, which is the one that goes right there. Okay, so replace this capacitor in here. This is the coupling capacitor. Capacitor 4 has been changed out. This one here was the one that was leaking all over the place, and that was this one right here, if you can see that. And this one here is the same size as that one, but it doesn't seem, I don't know if it has a lot of high voltage on it, so I haven't bothered with it yet. This 1 watt resistor here, I don't have one in 1 watt, but it's reading high, but figure high voltage, I mean high resistance will pull down voltage more, so hopefully it'll still work. If not, I've got a lot of resistors to change. And I haven't gotten into the RF side of this because I was getting a signal through, And so now I'm just trying to deal with the audio side. So I ran the lines back in from the output transformer. And so they're wired back in, plugged back into the socket for 41, which is down here. I've disconnected the leads that went to the field coil and the rest of the speaker, just so I get the speaker out of here, because I had too much stuff going on. I was worried about damaging it. So once I get that ready, then I'll just go ahead and trim this back and solder those to those posts. While I was at it, here's where that bias cell goes. And so I pulled it out, and here that is. Let me see if you can see that. So if I try to measure the voltage of this guy, he actually has a small amount of voltage, strangely enough.
Okay, let's measure that little bias cell. It's supposed to read 1 volt, 1.5 volts, so it's definitely not got anything left to it.
0.01 volts. So that's dead. All right, so I'm going to check over everything that we see here. Again, make sure I didn't make any mistakes. Double check all my connections, double check to make sure I didn't forget to solder something. And then if it all looks okay, then I'll hook up the speaker and we'll start looking at doing a quick power up and see how it works. So the question was what to do with this, or about this bias cell. I've seen where people have been able to rejuvenate these things. I may give that a try. I was also talking about using a watch cell, or you could just put a 10 meg ohm resistor to chassis and maybe that works. I don't know, but I thought for the purposes of what we're doing here is I don't have any of that set up. So what I've done is I've taken the cell out and I've wired in a couple of jumpers. And so what I thought I would do is I've got a couple of these DC-DC converters that I bought a while back. This is a buck converter, and pretty inexpensive, I must say. And this particular one will handle an input of 3 to 40 volts DC and give me a regulated output of between like 1.5 to 35 volts DC. And I can do that by adjusting the little trim pot that's on here. And so what I thought I would do is set this thing up for a fairly low voltage. Let's say like I think it can go down to like 1.25 volts. And if I'm lucky enough to get this thing working, I thought I could play with this voltage while reading what the voltage is and see if it really makes any difference in terms of what the voltage is. Can I get by with a 357 cell that I think is 1.55 volts? Or do I need to do something to get down to a lower voltage? I don't know. But I figured if we get this thing working, I'll have this thing hooked up along the side and I can tweak this little pot and we can see what different voltages work or not, and or just confirm it doesn't really matter. So just kind of demonstrate this for you. You can see the voltage there coming out of the unit. So as you get onto this little trim pot, you can adjust this and its voltage will start to go up. You see that okay? So like there it's 2.5 volts. I can bring it on up 3.67 volts, and it won't be able to go higher than what the batteries are providing, which is 4.5 volts. But like I say, it does give me a regulated supply. So I thought what I'd do is start down as low as I can get it, which I believe was like 1.25, somewhere around in here. And then as I play with the unit, I could maybe tweak this and see if it really makes any difference in terms of how that bias is set. I can bring it up to 1.5 or down to 1.25 and just see if it really likes being in that region or not. Anyway, it just gives me a way to experiment. Okay. So I'm ready to prep for putting the speaker wires back onto the this terminal strip that was mounted on top of the output transformer, if you remember that when I was trying to get it off. So here are the two leads that go into the field winding part of the coil, and then these are the two lines that come from the humbucker, which is inside there, and they tie with these two voice coil leads to the output, those three posts on the back side of the output transformer that mounts here. We'll get to that a little bit later. We just get these stubs off and get ready to weld, solder back onto this, and then we'll work about the output transformer, and then we'll hook the leads back up to here. I want to clean this up first. Got this piece of wood back here just to try to prevent any accidents from the soldering operation to get on the speaker cone. Okay, so I've stripped back the leads a little bit that go into the field coil, and since those are actually those are the humbucker coils, and since they're magnetic windings, they've got enamel on them, so we need to just make sure they're clean. I'm going to use a little bit of sandpaper to remove the enamel off of the winding wire. The windings need to be insulated from each other, otherwise it's just a short. Years ago I worked with a guy that he was a degreed engineer, and he didn't understand that these things had to be insulated from each other. So one time we wrapped up something with some insulated wire around a core and got a magnetic field out of it, and he didn't understand how it worked because it was insulated. And so it's not uncommon for people to not really know this. I'm sure if you're watching this you knew this, but maybe not. So anyway, these things need to be stripped of the insulation so that you can solder to them. Otherwise they'll repel the solder as well. They don't want to be soldered. There's ways of also doing this with heat. A lot of people like to use some style and use a Bic lighter and burn it off. I'm not going to risk doing anything like that to something like this, because I don't have a lot of wire to work with. If I mess something up, catch the cloth on fire. Okay. I think these humbucker coilers wires are going to be okay to go. I may put some flux on them to make sure that they take the solder well. Once I wind them up, they're not going to want to cooperate. It's not a thick coating. I think that's okay. Alright. I'm going to assemble the output transformer back on here, and then that'll give me something solid to work on, and then we'll get the soldering going. Yeah, so what I did was I had taken a Sharpie and put a black dot right there on the lead that went to the third tie post, which ties to this tinsel wire. The yellow goes to the middle terminal, and the last tinsel wire that goes to the voice coil goes to this third post by itself. So let me see if I can try to get this going, and it's going to be pretty tedious. I'll probably speed you up, but it'll take me a while. The battery died again, and I was on a roll, so I went ahead and got everything wrapped up here. So I got the finished up soldering the connections into the speaker, and they say it's kind of ugly, but good news is once it's in there it's hard to see it. Alright, so I've flipped it back around, and I've attached the tubes, put the tubes back in, and I placed in a couple of new tubes that I picked up. They're not new old stock. I'm pretty sure they're poles, but I've got another 41 and another 75 that I have in here. I'm still running the 66 and the 80 that I have. I have another 80 in case it dies, and I've got another 66. I didn't replace the converter tube, the 6A7 I may do that if I get everything working. I may go pick up one of those because it seems like I remember it's got a one of the tests was pretty weak. But yeah, so I think what I'm going to do is throw the power to it. So what I need to do is I'm going to flip it back up, and I'm going to connect up that biasing system for the bias cell that I was talking about earlier, and then we'll do a first power up and see how she does, and see if we get any noise out of it, and then we'll see what to do after that when we get a result from that. All right, so I'll go ahead and start doing it. I'll just leave the camera going.
Here you can see what the underside looks like. It's pretty much what you looked at earlier. Not pretty much, exactly. Back up. Okay, let me hook up the biasing system again. And find out where to do it.
Positive lead actually goes to chassis, so that will go to this connection here. And then the negative lead is what provides the bias, and that connects right on the other side of this 1 meg resistor. And then here is the buck converter right here with the adjustment screw right there. And then I'll see what I've got the voltage set at. So I'm going to set it for 1 1/4 right now, and I'm going to take the voltmeter off because I want to use it to track what I'm getting on my variac when I'm bringing the voltage up on the system. And then when I get it working, I'll bring it back and work on the biasing. So I'm currently set at about 1 1/4. Let's see if I can round that up. So remember where we had it. Okay, there we are. Regulated 1 1/4 volts. Okay, so we've got the bias set up, and I'm just going to leave it like that. Now it's time to set up to go for the power up. Okay, so plugging in. And we're sitting at 37.5 volts. And I'm ready to turn it on. Like I say, we're going through a variac and then a dim bulb tester. I'm going then through a isolation power transformer. Then I have a kilowatt for that I'm using for watching the wattage over here out of sight to the left. Okay, put something to it and see what we get. And we should be getting it now because we're powered and we're plugged in. So we're getting 3.5 watts. So I'm going to bring it up. I believe the sticker on the back of this thing said 50 watts. It's 50 volts. Got glow on the dial. Don't have tube glow yet that I can spot. Okay, let's bring it up some more. Let's bring it up to about 70. I'm pulling about 11 watts. Definitely getting glow on the bulb here. I don't think you can quite see it. Pull it just a little bit. You might be able to see that. So I'm at 70 volts. I'm seeing I think I'm seeing just a little bit of glow on the regulator. Bring it up some more. About 90 volts. I'm at 19 watts. Doesn't seem like enough power, does it? Got glow on both filaments of the regulator tube. Bring it up some more. Might as well make it 100. $30 watts. Not hearing anything. Still sounds like my audio circuit's dead. Still seems like my audio circuit's dead, doesn't it? I am getting a magnetic field, so definitely feel magnetism on the pole. I didn't feel that before.
The bulb's glowing. Okay, I'm at 50.8 watts at 117 volts, so I am at full power. But it's silent. Nope, I'm getting nothing. The output tube is glowing, and the rectifier tube is glowing. The rest of them I can't see. But they all feel a little bit warm, nothing alarming.
Okay, still seems like we've... Aha! Maybe I should try this. Alright, that's something. Getting sound. My voltage went up. Bring that back down a little bit. Don't know why. And my wattage went down, so let's see. Okay, I'm getting some noise. How about that? We're getting something. I've got it at full volume. So what position am I in? Full left.
Estas condiciones, ayúdenos para ayudar. Venga con su donación de aquí hasta el 30 de noviembre y hagamos que en esta... Trại nuôi lấy lông may quần áo. Liên Âu đã gây cấn bởi vì cái...
What does this mean? Am I about to break down? Who can I trust to repair this properly without being taken advantage of? Hi, this is Rona from Skeeter's Auto Service.
How about that? When was the last time this thing played?
Old-fashioned, unparalleled customer service meets the latest in technology.
I'm sure it's going to need alignment because I've changed wire dress, I've changed capacitors. I haven't done the RF section yet. might do a quick alignment on it just to see how it helps what we're doing here. But I think we've solved our problem with the radio. You know what happened first and how the cascade went, I'm not really sure. I could have maybe tried replacing one item at a time to see what effect it might have had, but if there was a cascade effect, I could decide, well, I fixed the audio output transformer, so I'll leave the capacitors alone and then just blow it again. And so I didn't want to have that happen. So I kind of had to go in there and take care of a few things. I knew that I wanted to take care of that grid coupling capacitor. And then once I kind of opened it up, once you kind of open it up and to replace something, you might as well replace the other items before you close it all back up. And also just not risk blowing something else up afterwards. Let me check my power draw. At 36 watts. I think I'm going to do a quick alignment here.